Hey guys, in this video I'm going to do a code review of a reader's solution to Fletcher's arrows. I've done this, I actually think I've even probably done it for this exact solution before, this exact challenge before, but different code, different chance to explore some different things here. So I'm going to set a time limit. I'm not going to spend more than 20 minutes on this. We're just going to go through a few things and just um, see what we can see here. I'll say that I think this code's actually in really good shape to begin with. I've already gone through it once, and I just kind of feel like, for the most part, it is doing what you want. So nothing big or problematic, but these are things that if I were doing an actual code review for production code, like these are things that I would probably point out and maybe suggest some changes to. So I think it's a good exercise. A, to see how this kind of stuff works, and B, to kind of just see some analysis of some code and stuff like that. The person who submitted this was specifically asking about, they had some issues with like multi-word enumerations and displaying those as strings. And then also the like the arrow, the expression body syntax for methods. So I have some of those that weren't working, and I don't know why. I don't know the full details of what they had tried and what wasn't working, but I think I know maybe some of the places they were looking at. So maybe we'll get to that too here. But yeah, I don't want to spend too much time rambling here. I want to just kind of get into some of the things. The first thing I'll do is I'll say, like, all these using directives, like it's even graying them out. I don't need those. So I'm just going to delete it. Keeps the code simpler. I suspect all of those came in on accident. Like system.threading.channels, there was probably never any need to use that. This compiler services, XML serialization, like it probably came from starting to type something and then Visual Studio saying, "Oh, is this what you're looking for?" And then like typing a little bit further and like Visual Studio interpreting that as, "Oh yeah, you want to add in this thing," and then the person's like, no, that's not what I want, back up. But it had already, like, you undo like you're down here making a change, and it adds the using directive at the top, and it also like adds a thing down here, and you fix it down wherever you're editing the code and leaves this here. So it's one of those things that, like, if there's a using directive that is not needed, I will always clean it up. I don't need any of that stuff that isn't actually necessary. This person is using like the program.main style. My preference for something like this is actually not that. I'm not going to change it here. I think it's okay. But one thing I will say is, in this case, at this point in the book, we've not talked about namespaces, but I'm going to take this suggestion here. Yeah, to file scope namespace. It removes one level of indentation. It's better. So just doing namespace this, everything in the file goes in there, and I think that's an improvement. This is complaining about the name not aligning with the project name. I assume their project name probably was Fletcher's arrows like this. And they probably tried to use an apostrophe and couldn't, or I don't know, but an apostrophe isn't legal in an identifier like a namespace name. So it's got that. I might have done it like that, but it doesn't matter much. Actually, I might have done it more like that. But again, that's nitpicky. It doesn't really matter. So let's see. I'll also say that I'll always put a blank line in here. Like, you should use white space to help make the code easier to understand and see. So using white space to help you see the structure of the code is a really good thing. And one of the things that you can do with that is add in a blank line between important elements, like between type definitions. I think, like, depending on stuff, I won't always put a blank space between, before and after a loop, but I often do. So it just kind of depends. Like, I think this white space here looks pretty decent to me. I don't have any problems with this white space. This is a local function, isn't it? Yeah, it is. So I'd put one in there. I'd put one right here. I'd put one here. So just like I said, adding the white space in here to kind of help create help the structure stand out visually, helps the code be easier to read. And I think that is a good thing. Any more? Nope, that's it. And actually, there's some extra blank lines down here that I'm going to remove. Oh yeah, there's there and there. All right. So with that done, like these right here, I wonder, the person was asking about the expression body, that, the fat arrow syntax. Um, these feel like a really good candidate for that. And the way you would do that here, like you remove the curly braces, you remove the return, and all you're left with then is the expression that produces the value that this returns. So all you would really do here is you just say arrow, the arrow operator, not to be confused with the arrow class, new arrow. And you just do the same thing here too. And by the way, I think this is going to suggest, nope, it's not. Transform parameters. Nope, don't do that. Stop. I've sometimes it'll suggest convert it to an expression body. So I assume that was maybe the place that the person was asking about. How do I do that? How do I get it to use the expression body? That's it. So this person, given that they've got this create, beginner marksman, like this is actually not just Vin Fletcher's arrows. This is kind of the whole sequence, like the Vin's trouble, where you deal with like accessibility modifiers levels, the properties of arrows, where you use properties, and arrow factories, because this is the factories. So there's that. Let's see. I think this right here also feels like we could maybe turn it into an expression body. So I'm going to start, actually, this might be suggesting use a switch expression. So I'm going to just start with this. And I think, like, consider the code here. This is a switch, and then it's case this, return, case return, default return. For me, and this is a really good candidate for a switch expression, I think for me, switch expressions are a lot more readable, as long as they're like a good fit. And I'll usually put in some white space. Again, white space to make the code easier to understand at a glance. Like I said, it's very tabular. It's very table-like. Here's the input and here's the result. And so you can just, like, it's easy to just see what's going on there. But now with this, then we actually can, once again, like we remove the curly braces, and since the whole thing is just a return some, in this case, fairly complicated expression, but return some expression, we can just replace this with the arrow like that. Now, what's interesting about this is, yeah, okay. I do want to unindent that. What's interesting about this is just how, like these curly braces almost look like they're the curly braces for the method. They're not. They're curly braces for the switch expression. But it does create this like visual, like I have this thing, this method, and it kind of, in this case it does this, and in this case it does this. If you've done any programming in a functional programming language, F# is an example of that. Haskell is probably the best example of that. You will often write methods that are just these little, like you define the method and say, if you have a method with a specific parameter, then here is the body of that method. And if you have, I'm getting into the weeds here. I'll stop. But the point is this actually starts to look like how you define these like sort of piecewise functions in a functional programming language. And I kind of like that, although maybe that's because I've done programming in a functional programming language. Anyway, there's that. This one, get fletching, seems to be like it's like this person's already using expression bodies really well in some of these other places. Now, I missed white space there. I might put white space there too, and maybe here as well. I don't always put it between every member here, like all these fields live together. But one thing that I will say is fields, the convention is you should put an underscore before your private fields. So I'm going to do that here. There, renamed. And now I don't need this dot. And then the other thing is so the default accessibility level for a class. Well, the default accessibility level for a class is internal, except, hang on a sec. Let's see what this is inside of. I think this might be inside of the, yeah, it is. All right, so one thing I will say is this class is inside of the program class. So it's a nested class. I'll make the suggestion, like the book hasn't actually talked about nested classes and doesn't until almost the end of the book. A lot of people accidentally start making nested classes. There's obviously a use for nested classes, and you should use it when the time is right. That is usually only when the type is like intimately associated with the container class. And so a lot of times nested classes will be private nested classes because you want another class to be able to make objects of that type, but you don't want the whole rest of the world to even know they exist. And so you just make a private nested class or a private nested enumeration to just like do this little thing inside of inside of it. It's implementation details of that class. That's, I think, the time that nested types, nested classes, nested enumerations make sense. Every once in a while, a public nested class will make sense. It's kind of rare. But what I would suggest is this should probably be public. Same with this enumeration, public. Same with this enumeration, make this public. I don't really see a reason for this to be internal, so I'm going to make it public. And I'm going to take the entire class here and both of these enumerations, and I'm going to just put them right up here at the top level. Because that's where they, like, to me, it makes sense for them to just be their own thing. Like this is the reasonable default that I think you should aim for. Is if you don't have a compelling reason to make a nested class, keep it at the top level. And like I said, I made all these public. Public means that they can be used inside of the project, but also from another project. Not that we are going to like share this code with anybody who would have it, but it allows these decisions to be made at different levels for different reasons. We don't have, just because we eventually decide to package this up into a library that gets reused doesn't mean we have to revisit every decision we've made about accessibility levels of things inside of it. So you kind of write the class or assuming, well, I don't know what this is going to be. So let's just assume that it is shared publicly. So what should these look like in that case? And here, like I said, that to me feels about right. All right. Okay, so I did notice this arrow class. It's telling me, hey, these things can be marked read-only. Actually, right now, that thing that's coming up says, hey, you could name it, you could leave off the underscore. Somehow on this computer, I've misconfigured it and told it, don't prefer the underscores. It is conventional for private. Like, it's misconfigured. It could make sense if I have my own personal style and I've intentionally decided I'm not going to do what every other C# programmer does. You're allowed to do that. But I think you want to make an intentional choice of the convention doesn't make sense for me or for this project or whatever it is. And so I'm going to make an intentional choice to go against the grain, do something that the rest of the C# world doesn't do. That should be rare. A lot of language features assume you're following conventions, and conventions are well suited to the to the language features. Like they work together. If you violate the normal conventions of C#, then it may make things harder for you than necessary. Anyway, I misconfigured it, so it's telling me that you can leave off the underscores. Ignore those. But at one point it was saying you can make these read-only, but it was only telling me you can make them read-only for a couple of these. So one of the reasons why we didn't see it for all three of them, because I really do think we could just make all of these read-only. is that one of these, this one right here, has a setter. So I do want to look at this property, which feels a little off. You might call it a code smell. It's called, like, the property is called get shaft. Yet it has a setter, and so that just strikes me as being a little bit weird. This is grayed out because it says it's never used, and I trust it on that. So what I'm actually going to do is I'm going to delete this, which now fixes my compiler error here of this. Well, I think the compiler error was here saying that it's read only. You can't modify it here. So if I just delete that, now this, like, it was never used anyway, so we just delete it, keep it cleaner, and now this is simpler. It's even better. In fact, one thing we can say is, well, now at this point we could actually just do an expression body for the whole property, right? We just do that. Now it's even simpler. Okay. But there's a little bit more cleanup that I want to do here, and that is that, and this ties into the earlier challenge of the properties of arrows challenge. We want getters and setters because they give us the ability for a class to protect an object, to protect its own data, and to have it creates this boundary that allows us to have flexibility about what we do on the inside. We can change our minds about what's happening inside of the arrow class without affecting anyone else. If you have a public field, then everybody knows that that thing is stored in a variable of a specific type. And I mean, you may never change it, so it may not matter, but one of the big things we do with objects is we're trying to make it easy for us to build large programs that have a lot of complexity. I mean, when you have 100,000 lines of code, there's a lot to keep track of. And so we want to build elements, pieces, where we can, like, hide a lot of complexity behind a simpler like shell, a simpler boundary, interface, API, whatever you want to call it. And forget the details that are going on the inside. And the benefit of that is that, like, we don't have to, like, feel all the complexity of the whole program all at once. We can hop around from thing to thing and deal with just the complexity of the one little thing we're dealing with without having to think about the complexity of the rest of the program. So it solves the complexity problem, and then it also solves our ability to change things over time. Because, for example, if we said, you know what, for example, this stores it as an int. And if we ended up making all sorts of arrows and said that's too much memory to use an int, it would be really easy for us to say, you know what, I'm gonna turn that into a byte. But the problem is now all the rest of the code is broken because now the type being used is a byte instead of an int, right? So it makes it hard for me to change stuff, except that what I can do is I can make this a byte, and I can still have the property. I'd have to either change this, or I'd have to cast to a byte here to make that compile. But, like, everybody else is using this property does not need to change. Like, it gives us this flexibility to change things within the class, all the private implementation details within the class, without having to change the entire program to account for it. Now, this is a very small example, but at the same time, all of part 2 is about gaining the tools necessary to build larger programs. That's what objects are meant for. Objects and inheritance and interfaces and, like, all that stuff. That's everything we're doing in part 2 is about making it so we have the tools to build larger programs. With that said, the programs that we're building are still small, but we're trying to, learn how to draw a circle before we draw an owl. We're trying to learn how to run a mile before we worry about running a marathon, like that kind of stuff. Like, we need to learn the tools and start applying them in things that honestly probably don't really justify using them. Like, you could build this program with a lot less code by skipping the classes and the properties and all that stuff, but we're trying to get familiar with the tools so that we can use them when it starts to matter more as our programs get bigger. And we need these little blocks that, building blocks that are independent, changeable on their own, that without affecting anybody. So, anyway, I do think we have these here, and the point of properties is that properties give us the ability for somebody to ask about the current value of data that the class, the object is thinking about, and also potentially to set it, while also giving the object the ability to protect itself from stupid requests. Like maybe nobody should know what that is, so we can just have a private field and nobody is able to even ask about it. Or we can say you're able to set it, but only at certain times or only to specific values, and that the property allows us to control that. And even if we don't need to control that, it's still good practice to start with, to use properties, even if they don't need anything too fancy yet, because it gives us that wiggle room down the line to change our minds about stuff when and if we need it, versus just public properties. So we've got these here. Like this one got changed to a property. These two probably deserved to be changed to properties. But one thing I'll say is we at this point we should remove the get on it. Like it shouldn't just be get arrowhead. It should be that. And actually, I do want to do that, but I want to. If you do the rename, Control R, see. Hold down Control R, and then you let go of the R, but keep the Control held down. Okay, I don't know. You have to keep the Control held down, but you can see down here at the bottom, Control R is pressed, waiting for a second key of chord. So hit Control R again, and then it brings up the rename. So I just call this arrowhead, but I also don't need. I just want that to be a property, not a method. And same with this. There. So now I have 3 properties, one for each of these. And I think I might have broken something elsewhere. Let me go, because this should no longer be a method call. I feel like I feel like this should be a compiler error too. I'm not sure why it's not. Well, I will say that this down here, non-invocable member, cannot be used like a method. It's calling this out, and then there's another one here for fletching. So I don't know why it's not turning it red, but yeah, there we go. All right, I'm a couple minutes over what I said I was going to do, so I'm going to try and just wrap these up here. But one thing I will say is at this point, we maybe don't even need, we could maybe just not have these properties and just use auto properties. I think I think I'm gonna do this is fine, but we can have the compiler generate a bunch of this stuff for us. So we just have a getter for all of these. That is still settable from our constructor. I can just delete those. Curly brace. So we'll just set the properties directly here in the constructor. Use the properties, and that should do it. So now we got 3 properties that just, yeah. All right, there's only one other thing that I want to say about this, and that is I kind of want the cost to be part of the arrow class. There's always these questions of where should this logic live? And it isn't always obvious what should go where. Just because something's related to, say, an arrow doesn't mean it must live in the arrow class. It might mean that that's a good place for it. It probably means it's worth considering that. But in this case, I had hoped that the instructions kind of point people toward there should be like a cost method or a cost property in the arrow class. So I do want to get the cost calculation, which is just, I mean, it's this right here. I want to get this into the arrow class. And this shouldn't be too hard. Like this is, I think, just used in one place right here. And I think if I'm going to just cut this, and then I'm going to come down here and just stick it in here. And so now so this is arrow dot arrowhead. Before that was actually a captured variable from the main method. In this case, it's just part of ourselves. It is this object that we're in. So we have direct access to it already. I'm going to make this a public method so we can call it. And then we get the cost. I'm just looking at this right here where it makes this a double and this is a float. That it feels like more work than necessary. Like there's a part of me that's just like, well, let's just make this a double. Nope, double. Like why does it matter? And then we don't need to cast it. We can just return it. If you did want to keep it as a float, which is fine by me, then you do that as a float. The only thing here is this just needs to be a float literal, not a double literal. And then that's it. And then you can just do return all of that. And then at that point, why not just make it an expression body? Like that. And that is all you need there. We just need it right here. So, and this is supposed to be, you know, one of the nice things about this is now we can just ask the arrow for its cost, right? So I like that better. I might actually just squish this in here. To like some people, like you don't want these string interpolations to get too crazy. For some people, like these are really simple. Some people, this is pushing it. Like I said, this whole line is already kind of complicated. So is this line kind of complicated? And some people will say, well, I don't want to make it too complicated. And so I'm going to store it in a variable. If you want to do that, if you feel like that makes the code easier for you to understand, keep it that way. It's totally fine to leave it that way. For me, I don't having like ditching the extra variable. Like I like how this is set up. So I know this just says the price will be, and then we just ask the arrow for the cost. That to me is straightforward and I'm happy with it. The only thing is I actually do want to turn this into, like we did with these other properties. Let's just make it a cost property. That's it. We're done. So now it's a property. And like again, going back to the conversation earlier about like we can change our minds about things. Right now, this property computes the cost every time you ask for it. Pros and cons. The benefit is that we are not storing that data in our arrow object. So the arrow doesn't know its cost until you ask it and it computes it on the fly. That saves us memory. On the con, the downside is that this little bit of math is not much. It doesn't take that long to run, but it's more CPUs. There's a few more instructions that have to run to do that math. It really isn't much. I would not worry about it at all. But that is a common trade-off of I use more memory and save myself CPU, or I use more CPU and save myself memory. Did I say that right? You kind of pick and choose and you shift. I'll use more memory so that the CPU is faster, or so that's often a trade-off that you have to make. But again, if this were just a public field, then everybody would know that I've got a variable there, and it gets tricky to change it because it breaks things. If you just change it, if you want to change your mind and say, I no longer want to store that in a field. So using properties gives us the wiggle room to change our minds about how we do stuff, which is the benefit of like private fields in getter and setter methods, or in a C# world where we have access to properties. properties are usually the better choice than getter and setter methods. But yeah, so in this case, like if we decided I don't want to pay that CPU cost, I'm totally fine having an extra 4 bytes of memory in here. We could, in the constructor, we could run this code and just set our cost right here in the constructor, and then just have a field or a property that just has the cost, and then we don't have to compute it every time. So I'm now 10 minutes over, 50% over what I said I was going to do. There's more things I could talk about here, but like I said, I think this code's in good shape to start with. Oh, gotta fix this. This code's in good shape. Like I said, these are things that are helpful, I hope. Definitely food for thought. Like I said, nothing in here that's like definitely wrong, but things to be thinking about that should help make the code better. So, and I hope this is helpful not just for the person who submitted this and was asking for some feedback on it, but for lots of people. Just like I said, more things to think about. Everything that I touched on in here is stuff that a lot of people, especially people who are newer to C# and newer to programming, like everything that I've seen in here is exactly what comes up all over the place, which is, again, part of the reason I wanted to cover this in a video so that others could see the comments as well. But yeah, like I said, the starting point of this was in pretty good shape too. So I made some changes that I think are, I think they make it better. Like I said, a lot of that's subjective, so you might not. And so take the parts that you think make a difference, things that matter, and the things that don't, put them on the back burner. Maybe think about them again later, and maybe ignore them. Like it's totally fine to say, that wasn't helpful to me, so I'm gonna not worry about it. So your code is yours, and you own it. You're the one that has to maintain it, not me. So don't blindly trust me on it. But anyway, that's the review. I'll stop here. So thanks for joining me on this, and I'll see you again next time.